Welcome to Arizona State University's University Academic Success Programs. This video will cover the topic second derivative.
What is a second derivative?
With the help of second derivative of a function, we can determine the concavity of the graph. If the second derivative of the function is positive, then the function would concave up. And if the second derivative of the function is negative, then the function would concave down. Y is a function involving the variable x, that is, if y equals f of x, then the second derivative of y with respect to x is given as d square y by dx square. Recall that dy by dx is the first derivative of the function. I would strongly recommend you to go through the list of common derivatives before we jump into examples.
Okay, can we go through an example?
Sure, let us consider an example. Let us say we are required to determine the second derivative of the function f of x equals x cubed plus 2x square plus 3x.
Okay, how do we proceed with this problem?
In simple words, we take the derivative of the function twice. We first calculate the first derivative of the function and further proceed to differentiate the first derivative to obtain the second derivative. Let us begin by determining the first derivative. The first derivative, denoted by f dash of x, can be obtained by differentiating the function with respect to x. Thus, f dash of x equals d by dx of x cubed plus 2x square plus 3x, which equals 3x square plus 4x plus 3. Now, we have to determine the second derivative of the function. We differentiate the first derivative of the function obtained above once more to obtain the second derivative.
Okay, let me try. The second derivative of the function would be d over dx quantity 3x squared plus 4x plus 3 equals 6x plus 4.
That is right. The second derivative is denoted by f double dash of x and it is equal to 6x plus 4. Let us look at a practical example. Let us consider a car whose displacement is governed by the function u equals 6t square plus 8t plus 1, where u is the displacement and t is the time. Let us say we are required to determine the velocity and the acceleration of the car.
How do we find those quantities? And how can we relate to the second derivative?
The explanation to this question comes from the definition of velocity and acceleration. Velocity is defined as the rate of change of displacement. In other words, velocity v equals du by dt. Now, acceleration is defined as the rate of change of velocity. This means that acceleration a equals dv by dt. But we know that v equals du by dt. This means that acceleration a equals d square u by dt square.
Now I see the connection.
Thus, we can see that velocity is the first derivative of displacement with respect to time and acceleration is the second derivative of displacement with respect to time. Okay, to determine the velocity, v equals du by dt, which equals 12t plus 8. And then acceleration, which is the second derivative of displacement, is obtained by differentiating the first derivative, which is velocity. Thus, a equals dv by dt, which also equals d square u by dt square, which equals 12. Thus, at any instant, we can determine the velocity of the car, and it is also interesting that the acceleration of the car is a constant.
Okay, can we do an example involving trigonometry functions?
Sure, let us consider an example. Let us say we have a function f of x equals cos 2x and we are required to determine f double dash of x. We know that f of x equals cos 2x. The first step is to determine f dash of x. F dash of x equals d by dx of cos 2x, which equals negative 2 times sin 2x. To determine the second derivative, we differentiate f dash of x with respect to x. F double dash of x equals d by dx of f dash of x, which equals d by dx of negative 2 sin 2x, which equals negative 4 times cos 2x.
Okay, I think I understand the concept. In order to determine the second derivative, we begin by evaluating the first derivative and then to obtain the second derivative.
Perfect.